Good. So I model the 1890s, and my layout is set to connect the Pennsylvania Northwest PA oil country to northern New England mill towns by basically getting rid of everything between the Susquehanna and Merrimack rivers. See Rule 1. So I have both standard and narrow gauge. The narrow gauge is kind of based on the Munson Slate Railroad in Maine and a crossing. So the question is, how do I control the crossing, both from a prototype operator perspective and also from an electrical perspective? The standard gauge will run, maybe, if I'm lucky, DCC. The narrow gauge is probably going to be straight DC. So there's some electrical issues there. And of course, nothing more says New England like a ball signal. To give you an idea of the layout, the original track plan had the crossing where it's shown a bit further up. I moved it down more towards the stairway, but operators on the right side in the visible staging and on the left side in the main layout room really need to be able to see the crossing and the signal that controls it. So that gives you the sort of the physical presence. So I needed to move the ball up and down, provide controls on both sides of that stairwell to move the ball. I have to route power to the appropriate track through the crossing. And I was advised not to depend on just a 020 piece of styrene to separate DC and DCC signals. So what I have are isolation blocks on either side of the crossing, both standard and narrow gauge, that I have to route power to the appropriate isolation tracks and the crossing itself. And I'm doing this in a box with electronics to protect it from mostly my head bumping coming up from below and the water from the scenery on the layout. So the crossing, or the signal itself kind of got a little damaged, but more importantly, folks out there can't see it. So I have these little videos. I'm going to play the right video. No, I'm going to try to play the right video. Yeah. The right video shows the ball being pushed up and down from a stick or a small wire that goes underneath. The left video shows the control arm, and I'll talk a little bit about that in a minute. But this gives you an idea of visually what the operators would see. Now it's all on this fairly stable piece of cabinet, quarter-inch cabinet plywood that I will screw underneath the layout and then push, removing the signal itself. Push those two poles, one for the post and the other for the little control arm, up through the layout, and then I'll plant the signal back on. What mostly wanted to talk about was the construction of this thing. Couple of ways to get vertical motion. I decided to go with servo because I had a little bit of experience with them. A wire to push the ball up and down. The idea of actually making the loop that the prototype uses was about 3 steps too far. But because I'm using a servo arm, which has a rotary motion, I have to figure out how to convert that angular motion to purely vertical motion. For controls, I'm using Barrett Hill touch toggles, which look a lot like my Tam Valley turnout controls. They're actually little circle that you drill out and put into your panel. They have a multi-input contraption. You take 2 buttons, one on either side, and they look to the controller like a single button. So that solves one problem. I'm using relays to route power to the tracks. So I have feeds underneath the track for both standard and narrow. The relays set the frog power. If you think about a crossing, go back and look at it. You actually have 4 separate frogs. Each one gets a different power, either standard plus, narrow minus, etc. And then an Arduino to control it, because there's a fair amount of complexity in here. So the way an Arduino works is there's a setup routine, and then there's an infinite loop that just runs forever. And the infinite loop is shown here. You look for a button push. if you weren't pushed before and all of a sudden you got pushed, now it's time to do work. Remember, you've got the button pushed, move the ball, change the color on the buttons to show which standard or narrow controls the crossing. Change the track power by first turning off all the track power, then set the correct feed for the 4 crossing frogs, and then enable the track power for the standard or narrow gauge that controls the crossing. Now, if you were pushed before and all of a sudden you're not pushed, now you go to the not pushed state. Otherwise, you just loop around waiting for a push to happen. The other thing you have to think about in something like this is your initial state, your initial condition. And it's set up so that the initial state, when the whole layout powers on, is the track routing is standard gauge. The ball is down, which is the standard gauge controls the crossing setting, the buttons show green. That's also, by the way, the state of the system when the power's off, which is a feature. If I don't have some problem on the controller feed, I know that the system is in a known state for what I hope to be the most likely owner. So I mentioned I used relays. Now, logically, there's a 4-pole double throw relay that handles the frog crossings. Well, you can't get those in 5 volts. Jason Bachman said I just should have used it on a motive 12-volt relay, but I found this board that has 8 single pole double throw relays. The other 4 relays are the on-off for the standard gauge, plus and minus, and the narrow gauge, plus and minus. And to make sure I wired everything correctly, I took a picture of the relay board and then taped it to a piece of graph paper and drew out the track connections. So that's my essentially design document designed for the track relays. I used an Arduino Nano, which is a nice small board. On top of it, there's a thing called a shield. And the shield provides little screw connectors instead of the normal pins. And this goes to the primary rule: if you can't make it perfect, make it adjustable. So I wanted to be able to fiddle around and learn and adjust things, and also to make it easy to replace something if I let out the magic smoke, which of course I did. The relay board, there are 2 kinds of relay boards. Echo.
You guys have, I just turned it off.
Okay. One relay board works the way I wanted it to. So when the Arduino writes a signal to the relay, it toggles, it switches. There's another one that works actually like a flip-flop. Is you send it a signal and it remembers its state, and you have to change it by sending it another signal. So I had both, but this model relay is a lot easier to program. I bought these little things called buck power regulators because I have a 12-volt bus for accessories throughout the layout. One of them produces 7.5 as input to the Arduino and lets the Arduino then scale it down to the 5 volts the Arduino wants. There's a second one that produces 5 volts to drive the relay coils. Because the relay coils take a fair amount of current, I don't want to overdrive the Arduino. And then through the process of things didn't work the way I wanted, I realized I needed a separate power source for the buttons in the servo. Because what was happening when the relays would trigger, they would cause a voltage drop. And that started to look like a signal, because the way these digital things work is when the voltage goes from 5 to 0, at some point it decides something has happened. So if the voltage is going up and down, you get spurious signals. So putting a separate power source to the buttons in the servo fixed that. I also added a capacitor. I'm not sure if it does anything, but it helps smooth out some of these power surges. Hookup wire, everything's done with perf boards, and I built what I called little patch panels by gluing or soldering screw terminal strips to the perf boards for the various kinds of wiring. So there's one for +5, there's one for +12, there's one for each of the 4 tracks. And that way, again, if I screwed something up or if I didn't get it right, I could just unscrew the wire and reconnect it. I used a servo, like I said, they're nice and cheap. The Barrett Hill touch toggles with what they call the multi-input controller. And this basically takes an input from each of 2 or 3 buttons and makes it look to the controller like it's a single push. So that saved me some work. And then I got a nice big box, and the box itself was driven by the size of that relay board. So for those of you who are not in the room, here's a picture of the inside and the outside of the box. There's a lot of connections on here. If you count through it, it kind of makes sense. You've got the DC narrow gauge, plus and minus. You've got the standard gauge DCC, plus and minus. You've got the accessory power bus, plus and minus. You've got a line to each of the 4 frogs. You've got plus and minus for the standard gauge track isolation blocks and the narrow gauge track isolation blocks. And then you have these 3-pin connectors, one for the buttons and the other for the servo. So I knew I was going to have to worry about a lot of in and out. Now, those are Wago lever connectors that are just epoxied to the top of the box. And they work great. They handle disparate size of wires really well, and they're really easy to plug, unplug when you need to test things, change things out. The box itself will be mounted upside down underneath the layout. So it's hard to see on the left side, but there's actually a little lanyard, a little piece of string that goes from the plywood underneath all the electronics on the box to the box top. So when I unscrew, if I have to unscrew the box top, it won't go falling down. Most of the wiring you see there is track wiring. It's the lines in and the lines out for the track. And that's all on the relay in the bottom. That's really where the complexity is with this thing, at least from a wiring perspective. I showed the videos before. I just want to show the servo you can't see is slightly off to the right-hand side. The way I handled the motion here, when that arm pivots, there's a little bit of horizontal motion. And there's just a slot in the arm so that the vertical rod, go back to where I was. The vertical rod moves up and down, but if you look carefully, you can see that in that slot, it's kind of moving. There's a little bit of horizontal, I won't say movement, but distance in there. And that was one of the first problems I had to solve. Those little keepers are just pieces of styrene, and they're removable. So I can replace, which I'm going to probably have to do, or install the signal itself. Okay, all right. A lot of lessons learned. I mentioned the getting the horizontal movement out of the control arm. The Barrett Hill buttons work a little strangely. They use a single control line for both input and output. So what you have to do is, when it comes time in that infinite loop to see if the button's been pushed, you change the signal, the pin, to input. You check to see if there's a read and compare it to what you had previously. Then you turn that pin back to output and write the signal for the button color. That took a little bit of complexity to figure that out and get some of the timing right. I mentioned the 2 kinds of relays. I have both. I bought lots of extra parts and learned a lot about this, but I ended up with the obvious control relays just because they're simpler. But those were not obvious things I learned sort of the hard way in talking to people. I mentioned the problem with the relay, particularly the coil voltage, causing power drops, which caused voltage spikes, which generated spurious signals. And that really had me frustrated for a couple of days because I couldn't figure out why it worked when the Arduino was powered from the USB for programming, but it would not work when it was powered from the standard layout bus. Servos move at a constant speed. You basically tell the servo, position yourself to this angle, and it moves. Now, if you want a nice slow movement, what you have to do is move the servo 1 degree, which is its minimum movement, spin for a while, twiddle your thumbs, move the servo another degree, twiddle your thumbs. And I set that up in the program so that I basically tuned it to where I thought the servo was going slow enough to move the ball at a reasonable rate. Wiring standards are important, but following them is even more important. And if you put 12 volts into a 5-volt device, the magic smoke comes out. I went overboard, but it was a good thing. I had, I think, extras of everything, and I ended up needing an extra relay board. And somehow I think I messed up one of the Barrett Hill buttons. I have to replace that. And I mentioned those Wago lever connectors. Those are used all through my layout for any time I have to do a connection that I might have to undo. I had a lot of help from people on the railroad forums, especially early on, trying to figure out how to get that purely vertical motion out of a servo. Kevin Hunter at Barrett Hill. This works only because Kevin kept on helping me. I'd send him a message saying, it's not working and I don't know why. He'd come back and say, well, try this. Oh, okay. And then finally, I want to dedicate this to Don Ball. Some of you may have met him. He was up for Tour de Chooch a couple of years ago. He passed away suddenly, unexpectedly, about a year ago. But Don and I had talked about this. Don was a mech engineer. So the first guy I talked to, I said, can this be done? Was Don. And this is, the ball signal is dedicated to the late Don Ball.
So this is kind of broken, but the arm will move.
The video showed it.
Yeah, the video showed it a little bit better. The other thing I should mention is getting the tension on the lanyard is really critical to make this work. Yeah, that was about 2 days of swearing before I finally got the tension to get right. So the rest of the combination is pretty sturdy. It's this one arm that's weak. I think I know how I'm going to fix that. Yeah, and this will screw in from the bottom to the benchwork to be held in place. I got this source of 1/4-inch cabinet cutoffs that I use for jigs and projects like this. I glue them together when I need good heavy 3/4-inch, like for switch templates. So everything but this part is really sturdy. Trust me. Okay.
They have 1-foot squares at Woodcraft.
Yeah. These cost me, it's funny, a friend of mine said, hey, I saw those. You think you want some? I said, yeah. He said, well, they're 50 cents a piece. How many do you want? I said, all of them. And I think I came home with a box of about 60 of them. And I still have a lot of them left over, but I have used almost half that box.
When you get your Wago connectors.
The connectors are easy to find on Amazon. What's hard to find, Wago makes a bracket that you can screw in. You don't need them here because these are epoxy. But for my bench work, I find that I tried pressure sensitive tape. That didn't work real well. But Wago makes a bracket, and I got them from Newark Electronics. So you basically, it's a one screw, you screw the bracket into the bench work, snap the Wago connector in, and you're good to go. I can't say enough about these Wago connectors because they're just so convenient, so easy, and they work from about 20 to about 12 gauge wire. Actually, I think I put 24 or 26 in them with absolutely no problem. And that's what I use for track drops to the bus. Because the bus is, my bus is, I think, 16 gauge, and my track feeds are about 26.